Just something about radioactivity, because I had an erroneous notion of what radioactivity was. I thought that if you had something that had like a half-life of a day, and you had something that had a half-life of 1,000,000 years, it meant that the dude that was radioactive for a day is like for a day, and then I'm done. And the dude who's half-life for 1,000,000 years is like for 1,000,000 years, and then done. Okay, so you go, well, which one of these is more dangerous? Well, definitely the one that's got a half-life of 1,000,000 years, because that's got to be like radioactive forever. And the dude's radioactive for a day, that's not a big deal, right? Completely wrong. Okay, utterly backwards. The dude who's radioactive for a day is really, really radioactive. The dude who's radioactive for 1,000,000 years is hardly radioactive at all. Which one of those two is more dangerous? The one that's radioactive for a day, by a long shot. Okay, so your radioactivity is directly and inversely proportional to your half-life. So all these guys who have real short half-lives, very, very dangerous. But they're going away real quick. This guy, 2.3 million years, no problem. It's not going to hurt you. It's just not nearly radioactive enough. Now what about thorium and uranium? Both are naturally occurring materials. Thorium has only one isotope, thorium-232. It has a 14 billion year half-life. So when the universe is twice as old as it is now, thorium will have only decayed one half-life. What does that tell you about how radioactive thorium is? Hardly at all.
Someday looking at our descendants and to have them say, why did you give us this world that we have now? Why did you give us this world of energy poverty, of pollution, of war, of disease, when you knew there was a better way and you could have made it happen? You say, why didn't you do this? You knew about it and you could have made it happen, but you didn't. What's your excuse?